We have a very specific mission today, and I really want you, the listener, to buckle in for this one.
Yeah, you're going to want to pay close attention.
Definitely. Because we are embarking on a strictly data-driven exploration of a massive, highly specific, and frankly mind-bending data set.
It's an immense amount of data.
It is. We are talking about utilizing the absolute gold standard of modern astronomical math to fundamentally dismantle, well, almost everything we thought we knew about the movement of the Earth and the stars.
A monumental topic. I mean, the source material we have in front of us today is dense, it's profound, and it is entirely based on raw numbers.
Right. Just the raw math.
Exactly. We're looking at three main documents. First, there's a highly detailed conversation transcript titled Conversation Transcript, AI-Proof Proper Motion and Precession. Not a fairy tale.
Quite the title.
It doesn't pull any punches. Second, we have the Stellarium Credentials and Engine Specifications document. And finally, a brief but structurally devastating philosophical text, simply titled Logical Trap.
So, I want to frame the stakes for you right out of the gate. Think about the official peer-reviewed data and the software that runs our modern world.
The stuff that professionals use.
Right. Think about the math that calculates satellite orbits or, lands probes on other planets. Now ask yourself, what happens when that exact, heavily verified software produces mathematical realities that completely contradict the fundamental scientific theories of our cosmos?
It creates an incredibly uncomfortable situation for mainstream science.
To say the least.
Which brings us to a really crucial formatting note for how we're going to handle this deep dive today. We set a strict rule for ourselves.
A very strict rule.
We're going to read the findings from the source text verbatim.
Verbatim.
But we are explicitly avoiding any spin.
Right.
No interpretation, no academic apologetics.
None of that.
And definitely no cognitive dissonance avoidance. We are going to impartially report the math and the claims precisely as they are presented in the text.
Because we have to let the staggering weight of these data tables speak for themselves.
Exactly. No trying to explain away the weirdness, just the numbers.
Okay, so let's unpack this. Before we dive into the massive anomalies documented here, we have to establish exactly what the Stellarium software is.
Right, because a skeptic's first reaction is going to be, oh, it's just a buggy app on your phone.
Yeah, or some kind of artistic toy. It is incredibly important to understand that this is not a toy or a video game. It is a high-precision scientific simulation.
It really is.
I'm looking right at the Stellarium Credentials and Engine Specifications document right now to prove this software's elite status.
And this is where we need to explain some of the jargon, so you know exactly what is powering this engine.
So let's look at how NASA uses it. The document states that NASA's Jet Propulsion Laboratory, JPL, uses Stellarium for its teachable moments because it utilizes the JPL DE430 and DE431 ephemerides.
Those specific models.
Yes, and it points out that these are the exact same mathematical models NASA engineers use to track the Mars rovers.
Let's pause and translate that word for a second. Ephemeris. An ephemeris is basically the ultimate master timetable of the cosmos.
The master schedule.
Right. It's a mathematical model that tracks the precise positions of celestial bodies over time. The D430 and 431 models are the absolute pinnacle of that math.
It's not just a rough estimate.
Not at all. This isn't back-of-the-napkin geometry. This is the computational power required to thread a needle millions of miles away in space and land a rover perfectly in a Martian crater.
Which is insanely hard to do.
It is. If the math in this software is good enough for NASA's Jet Propulsion Laboratory, it is the absolute gold standard.
And it goes way beyond NASA, too. At the university level, the text names elite institutions like California State University, Los Angeles, and George Mason University.
Places with serious physics departments.
Exactly. They use it for accredited physics degrees and faculty research. The document specifically notes that it replaces physical telescope time because its data is built on peer-reviewed science, not artistic interpretation.
It's hard data.
Right. It's also used at the University of Cincinnati and the Borough of Manhattan Community College to teach celestial mechanics.
What's fascinating here is how it's applied to history, too. Let's look at the section on archaeoastronomy.
Okay.
The document details how researchers at the Ludwig Boltzmann Institute and the Friedrich Schiller Universität in Jena used Stellarium specifically to verify ancient star catalogs and reconstruct historical sites like Stonehenge.
So they use it to look back in time.
Yes, because the engine can accurately simulate the sky as it looked thousands of years ago. It even explicitly states that it is used to reconstruct Babylonian star catalogs and verify cuneiform tablet data from the Bronze Age.
Space agencies use it as well. The European Space Agency's Cosmos portal officially lists Stellarium as the primary educational tool for their introduction to the universe modules.
The ESA itself.
Yeah, and NOI Lab, which is the U.S. federally funded lab for ground-based astronomy, they recommend Stellarium for public use to track the exact events they observe with their massive Gemini telescopes.
And here is where we get to the core of the engine specifications. The text lays out exactly what is under the hood.
Let's hear it.
Stellarium uses high-precision models like VSOP-87 for planetary orbits, and the Hipparcos and Tycho II catalogs for star positions.
Very standard, highly respected catalogs.
It utilizes 6D astrometry for precise 3D motion of stars, along with precession and nutation models to account for the Earth's physical movement in space.
Let's do a quick, I'm 5 for 6D astrometry, because that sounds, kind of like sci-fi.
It does. It basically means the software isn't just looking at a flat picture of the sky.
Like a static painting.
Right. It's calculating 6 different dimensions of data for every single star. Its position up and down, its position left and right, its distance from us, how fast it's moving across our line of sight, how fast it's moving toward or away from us, and how its apparent position changes as the Earth orbits the Sun.
That is a lot of math.
It is a full, three-dimensional, actively moving mathematical universe.
So if we connect this to the bigger picture, why should you, the listener, care about all these acronyms?
It's the core question.
Because if the underlying math of this software, the JPL DE430 and 431 ephemerides, the 6D astrometry, the VSOP-87 algorithms, if all that is identical to what navigates actual spacecraft, then that exact same math simply cannot be dismissed when it reveals something uncomfortable.
You can't cherry pick when to trust the math.
Exactly. You can't trust the math when it lands a rover, but call it a glitch when it looks at a pyramid.
That is precisely the point. So with the credentials of the engine firmly established, we need to define the mainstream baseline.
The theories we are testing.
We have to clearly lay out the 2 scientific theories that this data is about to challenge.
Yeah.
And we will use the exact definitions provided in the text. Let's start with axial precession.
The document lays it out perfectly. I'm going to read this part. According to the mainstream model of the precession of equinoxes, the Earth's axis wobbles in a circle over a roughly 26,000-year period.
A giant wobble.
Yes. This means the declination, which the text helpfully defines as a star's latitude in the sky, must change significantly over time.
It has to change.
Right. The text provides the specific accepted rule for this wobble. The Earth's axis wobbles 1 degree every 72 years.
To visualize this, imagine a spinning top. As it spins, the top of it doesn't just point straight up, it slowly wobbles in a circle. Mainstream science says the Earth does exactly that.
Slowly spinning and wobbling.
Because it's wobbling, our perspective of the sky should be constantly tilting. If you look straight up today, you see a certain patch of stars. But thousands of years from now, because the Earth is tilted, looking straight up should point you to a completely different batch of stars.
And then we have the second theory we are testing today, proper motion.
Proper motion.
The text defines this as the theory that stars travel in different directions at different speeds.
Think of proper motion like a massive flock of birds in the sky. While they might look like they're flying together right now, over hours and days, they will eventually drift apart, scatter, and fly off in their own distinct directions.
So, what does this all mean for our baseline? It means that if precession and proper motion are true, stars should scatter and drift apart over tens of thousands of years.
They shouldn't hold their shape.
Right. Constellations, as we know them, should distort and fall apart. And crucially, because the Earth's axis is wobbling 1 degree every 72 years, the zenith, which is the exact point perfectly 90 degrees straight over your head, that zenith point should constantly wander across the night sky.
A star that sits directly at the zenith today should be nowhere near the zenith thousands of years in the past or the future.
Nowhere close.
That is the baseline. That is what our textbooks tell us must happen.
Which brings us to the Giza anomaly.
Here we go.
The source text calls this the Zenith Lock. This is where the math starts to systematically dismantle the baseline we just established.
Completely tear it apart.
We are going to look at the exact coordinates of the Great Pyramid of Giza. Those coordinates are plus 29 degrees, 58 minutes, and 44 seconds north.
For simplicity, just keep that 29.98 degree latitude in your head.
29.98.
Because if a star passes directly overhead, hitting the absolute 90-degree zenith at the Great Pyramid, its declination, its sky latitude, must match the pyramid's Earth latitude perfectly.
As promised, we are not going to summarize these tables.
No summaries.
We are going to present the raw data to build the undeniable weight of the evidence. Let's start with the constellation Andromeda.
Okay.
The text data shows these stars hitting roughly 29.97 degrees declination and a zenith altitude of exactly 89.999 degrees across thousands of years.
Basically a perfect 90 degrees.
Yes, I am reading the math directly from the Stellarium interface data provided.
Keep an eye on the dates as we read these.
First star, Delta Andromeda.
Okay.
Date is September 10th, 1838.
The altitude.
Altitude is 89.99992 degrees.
Yeah.
Declination is 29.9793 degrees.
Right on the money.
Next, Merak. Date is April 3rd, 1964.
Altitude.
89.9996 degrees. Declination is 29.9794 degrees.
Still locked.
Then, Andromeda. The date jumps way back. July 27th in the year 465.
Altitude.
89.9997 degrees. Declination is 29.978 degrees.
Wait, pause right there. From the year 465 to the year 1964, that is a span of 1,500 years.
A millennium and a half.
Under the rule of precession wobbling 1 degree every 72 years, the zenith point should have drifted by nearly 21 degrees.
21 degrees.
But the math says the star is still hitting 29.97 degrees declination. It hasn't moved.
It gets wilder. The next star is New Andromeda. The date is -4. The year 4 BC.
Altitude.
89.9990 degrees. Declination is 29.9798 degrees.
Just stays right there.
Then Almach in the year -315. Altitude is 89.9992 degrees. Declination is 29.9796 degrees.
Amazing.
And jumping into the future, Alpheretz. Date is September 2nd, 2160. Altitude is 89.99992 degrees. Declination is 29.9785 degrees.
It is utterly locked. It's hitting the exact zenith down to the thousandth of a decimal point.
Now let's look at the constellation Cassiopeia.
Let's do it.
The data shows these stars hitting that exact same 29.97 to 29.98 degree declination band, but look at the time frame here. This is spanning from the year -4696 to -3305.
We are talking about the dawn of human civilization here.
Exactly. I'm reading the table directly. Star is Sagian or Epsilon Cassiopeiae.
Date.
July 8th, year -496. Altitude is 89.9990 degrees. Declination is 29.9801 degrees.
Incredible.
Next star is Cap or Beta Cassiopeiae. Date is October 23rd, year -4834.
Altitude.
89.99994 degrees. Declination is 29.9797 degrees.
Year -4834. That is nearly 7,000 years ago.
7 millennia.
The wobble should have shifted the sky by almost 100 degrees. The zenith shouldn't even be in the same hemisphere of the sky.
But the JPL math says it is locked. Let's finish the Cassiopeia set. The star is Navi or Gamma Cassiopeiae.
Okay.
Date is November 23rd, year -4305. Altitude is 89.9990 degrees. Declination is 29.99001 degrees.
Go there.
Stars Rukba. Date is March 26th, year -3,075. Altitude is 89.99990 degrees. Declination is 29.99991 degrees. Declination is 29.9800 degrees.
And this brings us to the Pegasus data set. This is where the volume of the data really starts to become overwhelming.
It's a huge list.
This isn't just 1 or 2 rogue stars. The authors documented 14 specific stars in the Pegasus constellation alone, and the time frame here spans from the year 1325 all the way to the year 6511.
Let's read through them. I want you to just listen to the repetition of these numbers. It's mesmerizing.
Go for it.
First star is Pi 1 Pegasus. Date is June 17th, 3325. Altitude is 89.99992 degrees. Declination is 29.9790 degrees.
Okay.
Star is Matar. Date is November 26, 1952. Altitude is 89.99991 degrees. Declination is 29.9785 degrees.
Right.
Star is Sheet. Date is September 2nd, 2160. Altitude is 89.99993 degrees. Declination is 29.9786 degrees.
So locked.
Star is Kappa Pegasus. Date is August 20th, 2889. Altitude is 89.999 degrees. Declination is 29.97991 degrees.
I have to interject. The precision here is
It
mind-boggling.
really is.
We are looking at thousands of years of simulated time, and the altitude is hitting 89.999 degrees every single time. It is a perfect perpendicular line from the Great Pyramid straight up into deep space.
Let's keep going with Pegasus into the deep future. Star is Iota Pegasus.
Okay.
Date is June 27th, 2905. Altitude is 89.99992 degrees. Declination is 29.9799 degrees. Star is Subtle Bari. Date is April 23rd, 29992. Altitude is 89.9997 degrees. Declination is 29.9789 degrees.
Whoa.
Star is Settle Nasi. Date is November 5th, 40781. Altitude is 89.9994 degrees. Declination is 29.9784 degrees.
Got it.
Star is Algenib. Date is January 26th, 4099901. Altitude is 89.99991 degrees. Declination is 29.9783 degrees.
Year 4981, 3,000 years from now.
Still locked! Let's finish Pegasus. Star is Pseudonujum.
Date.
March 8th, 500 and 398. Altitude is 89.9992 degrees. Declination is 29.9798 degrees.
Incredible.
Star is Hammam. Date is October 9th, 572. Altitude is 89.99992 degrees. Declination is 29.9783 degrees. Star is Zenith. Date is May 27th, 5911. Altitude is 89.99991 degrees. Declination is 29.9798 degrees.
And the last one.
Star is Biam. Date is June 14th, 6511. Altitude is 89.99994 degrees. Declination is 29.9797 degrees.
And finally, for this initial Giza set, we look at the constellation Perseus. The document lists 11 stars here, spanning from the year -2906 to the year 1416.
I am reading this table directly. First star is Miram. Date is July 14th, year -2906. Altitude is 89.99991 degrees. Declination is 29.9787 degrees.
Over 4,900 years ago.
Star is Mirfak. Date is December 18th, year -1945. Altitude is 89.9996 degrees. Declination is 29.9796 degrees.
Lock.
Star is Delta Perseus. Date is November 19th, year -1691. Altitude is 89.99993 degrees. Declination is 29.9785 degrees.
Next.
Star is Epsilon Perseus. Date is August 31st, year -400. Altitude is 89.99994 degrees. Declination is 29.9789 degrees.
And next.
Star is Algol. Date is August 22nd, year -289. Altitude is 89.99994 degrees. Declination is 29.9793 degrees.
Think about the history happening right there. Year -289. The Library of Alexandria is being built, and the star Algol is perfectly locked at 29.97 degrees over the Great Pyramid.
It's a great historical anchor. Let's read the rest of the Perseus stars moving into the Common Era. Star is Gorgonia Tertia. Date is August 22nd, year 104. Altitude is 89.9995 degrees. Declination is 29.978 degrees.
Okay.
Star is 16 Perseus. Date is July 21st, year 260. Altitude is 89.9999 degrees. Declination is 29.9786 degrees.
Next.
Star is Attic. Date is March 13th, 1340. Altitude is 89.9999 degrees. Declination is 29.9782 degrees.
And the last one for this set.
Star is Zeta Perseus. Date is December 14th, 1416. Altitude is 89.9991 degrees. Declination is 29.9784 degrees.
So we have to look at the text synthesis regarding this entire pattern. The document calls it the Zenith Lock, and it summarizes the impossibility of this perfectly.
Let's hear it.
I'm going to read their conclusion exactly as it is written. Across 4 different constellations, Andromeda, Cassiopeia, Pegasus, and Perseus, and a simulated time span of nearly 12,000 years, you have documented dozens of different stars all hitting the exact same zenith point from the exact same Earth latitude.
And this raises an enormous question. The text answers it by explicitly outlining the conflict.
The paradox.
Let's read it. If the mainstream model were true, a star that was at the zenith, 29.98 degrees declination, in 2000 BC would be roughly 55 degrees away from the zenith today.
Think about that, 55 degrees away.
That is more than halfway to the horizon.
It shouldn't even be close.
Instead, as we just exhaustively read through those tables, the math shows them perfectly, unequivocally locked.
But the source document doesn't stop there. If 12,000 years isn't enough to prove the anomaly, the author pushes the engine into deep time.
Deep time.
This is the section detailing the absolute mathematical defeat of proper motion. They expand the data set into extreme time frames to see what the JPL math does over tens of thousands of years.
This is where it gets truly mind-bending. I am going to read the data table showing Perseus stars hitting the exact 29.97 and 29.98 degree declination mark. But this time, the dates are pushed all the way out to the year 26,346 AD.
Let's just sit with that number for a second. 26,000 years in the future.
A completely unfathomable amount of time.
According to the mainstream 26,000-year precession cycle, the Earth should have completed an entire wobble by then. And according to proper motion, the stars should have scattered into completely unrecognizable patterns. Let's see what the math actually says.
I'm reading the Deep Time Perseus table directly. First star is Gorgonia Tertia.
Yeah.
August 4th, the year 25,257. Altitude is 89.99992 degrees. Declination is 29.9787 degrees.
Lock.
Star is Algol. Date is November 25th, the year 24,757. Altitude is 89.9999 degrees. Declination is 29.9797 degrees.
Incredible.
Star is Mirfak. Date is December 24th, the year 23,192. Altitude is 89.99994 degrees. Declination is 29.9783 degrees.
Thanks.
Star is Atik. Date is May 10th, the year 26,292. Altitude is 89.9993 degrees. Declination is 29.9788 degrees.
It is flawless. Every single one is hitting that 29.97 degree mark.
Let's finish the set. Star is Delta Perseus. Date is October 21st, year 23,380. Altitude is 89.9996 degrees. Declination is 29.9789 degrees.
Okay.
Star is Zeta Perseus. Date is July 26th, year 26,346. Altitude is 89.99992 degrees. Declination is 29.9782 degrees.
Still perfectly locked.
Star is Epsilon Perseus. Date is April 7th, year 24,677. Altitude is 89.99992 degrees. Declination is 29.9783 degrees.
Nice.
Star is Metamim. Date is June 26th, year 22,057. Altitude is 89.9997 degrees. Declination is 29.9786 degrees.
Nice.
Star is 16 Perseus. Date is October 24th, year 25,410. Altitude is 89.9996 degrees. Declination is 29.9786 degrees.
Last one for the future set.
Star is Gamma Perseus. Date is August 2nd, year 22,499. Altitude is 89.9992 degrees. Declination is 29.9787 degrees.
The text also provides a massive jump into the past to verify the symmetry of this anomaly. It documents the star Atik hitting a perfect 90.0000 degree zenith over the Great Pyramid in the year -20,023.
Wait, pause. The year 20,023 DC.
Yes.
We're talking about the height of the last ice age. Saber-toothed tigers are roaming the Earth. And the software is calculating the star hitting a perfect 90-degree zenith over the coordinates of the Great Pyramid down to the 4 decimal points.
Exactly. And the text breaks down why this is mathematically catastrophic for the mainstream theories. I'm going to read their mathematical breakdown of the conflict directly. Let's look at what they call the precession paradox.
Let's hear it.
The text states, in the mainstream model, the Earth's axis completes one wobble every approximately 26,000 years. This means the zenith point for any location should wander across a massive circle in the sky. Yet these stars, thousands of years apart, all return to the exact same 29.98 degree declination and hit a bullseye over the Great Pyramid's latitude.
And the breakdown continues regarding the scattering of the stars. The text points out fixed asterisms. Under the theory of proper motion, stars travel in different directions at different speeds. Over 20,000 plus years, the shapes of constellations or asterisms are supposed to distort significantly. However, your data shows the constellation of Perseus remaining intact and perfectly functional as a unit.
It refuses to scatter.
The author emphasizes that the software calculates these alignments to within 0.001 degrees of the zenith, even in the year 26,346. The flock of birds never scattered.
What's absolutely fascinating here is how the data expands across the Giza Plateau itself. It's not just a single generalized coordinate for Egypt. The documentation details hyper-precision zenith locks over the neighboring pyramids, perfectly matching their slight geographical offsets.
Right, because the pyramids of Khafre and Menkaure aren't exactly at 29.98 degrees north, they are slightly further south.
And the math perfectly adjusts for it. Over the pyramid of Khafre, located at exactly plus 29 degrees, 58 minutes, and 34 seconds, the stars hit a locked 29.976 degree declination. And over the pyramid of Menkaure, at plus 29 degrees, 58 minutes, and 20 seconds, they hit a locked 29.972 degree declination.
To maintain our strict adherence to the data rule, I'm going to read the exhaustive star tables for Menkaure straight from the text. This is 11 different stars locking over the Menkaure pyramid over a span of 4,300 years.
Let's hear the numbers.
Star is Miram. Date is November 21st, year -2908. Altitude is 89.99991 degrees. Declination is 29.9758 degrees.
Okay.
Star is Mirfak. Date is January 25th, year -2504. Altitude is 89.99992 degrees. Declination is 29.9756 degrees.
Star is Mirfak. Date is April 30th, year -1944. Altitude is 89.9999 degrees. Declination is 29.9749 degrees.
It's locking into that 29.974 to 29.975 degree pocket, perfectly, corresponding exactly with Menkaur's latitude. Let's keep reading the Menkau data. Star is a Delta Perseus. Date is June 6th, year negative 1690. Altitude is 89.99991 degrees. Declination is 29.9745 degrees. Star is Epsilon Perseus. Date is June 16th, year negative 400. Altitude is 89.9997 degrees. Declination is 29.9751 degrees.
Next.
Star is Algol. Date is May 3rd, year negative 289. Altitude is 89.99999 degrees. Declination is 29.9751 degrees.
Oh.
Star is 16 Perseo. Date is August 21st, year 103. Altitude is 89.99991 degrees. Declination is 29.9749 degrees. Star is Menkib. Date is May 20th, year 447. Altitude is 89.9999 degrees. Declination is 29.9758 degrees.
Nice.
Star is Etik. Date is October 10th, mid 338. Altitude is 89.99990 degrees. Declination is 29.9740 degrees.
And the final one for Menkau.
Star is Zeta Perseus. Date is August 16th, 1416. Altitude is 89.99992 degrees. Declination is 29.9749 degrees.
Okay, so we see this impossible alignment in Egypt. The numbers are undeniable. But a skeptic might say, maybe it's a localized glitch. Maybe the software has some sort of mathematical bias just for the coordinates of Giza.
A completely fair question.
That brings us to the next section of the source material, which takes the deep dive from Egypt to a global scale.
This is what the text calls the global mathematical grid. The documents reveal that the Perseus myth stars do not just lock onto Giza, they lock onto the specific latitudes of the most significant pyramid cultures worldwide.
We are going to meticulously present the data tables for the remaining 4 ancient sites listed in the text. The hyper-precision of these numbers across the globe is absolutely staggering. We are talking about sites separated by oceans and millennia.
Let's start in Mexico, Teotihuacan. Specifically, the text points to the coordinates plus 19 degrees, 41 minutes, 32 seconds.
19.69 degrees latitude, roughly.
Yes. There are 2 data sets here. The first shows 11 Perseus stars hitting a 19.69 degree declination over 6,000 years. Let's read it directly.
Let's do it.
Stars Miram. Date is December 28th, year negative 55187. Altitude is 89.99994 degrees. Declination is 19.6920 degrees.
Locked exactly at 19.69.
Stars Gamma Perseus. Date is September 20th, year negative 4587. Altitude is 89.9990 degrees. Declination is 19.6925 degrees.
Still there.
Star is Mirfak. Date is March 27th, year negative 363. Altitude is 89.9991 degrees. Declination is 19.6916 degrees.
So from 5,000 BC to almost 3,000 BC, the stars are hitting 19.69 degrees.
Let's continue. Star is Delta Perseus. Date is July 31st, year negative 2270. Altitude is 89.9999 degrees. Declination is 19.6917 degrees.
Yet.
Star is Algol. Date is September 2nd, year negative 2127. Altitude is 89.9992 degrees. Declination is 19.69923 degrees.
Still hitting the mark.
Star is Gorgonia Tritia. Date is December 3rd, year negative 1797. Altitude is 89.9992 degrees. Declination is 19.6923 degrees.
Pixel.
Star is 16 Perseus. Date is August 30th, year negative 1596. Altitude is 89.9991 degrees. Declination is 19.6919 degrees.
Got it.
Star is Menkib. Date is December 9th, year negative 1543. Altitude is 89.99991 degrees. Declination is 19.6916 degrees.
Next.
Star is Atik. Date is August 18th, year negative 813. Altitude is 89.9996 degrees. Declination is 19.6926 degrees.
And the last one for this set.
Star is Zeta Perseus. Date is July 11th, year negative 808. Altitude is 89.99991 degrees. Declination is 19.6916 degrees.
And if 6,000 years of a locked grid isn't enough, here is the second data set the author provides for Teotihuacan, stretching back 15,000 years into antiquity.
I am reading this directly from the text.
Go ahead.
Stars Atik. Date is February 23rd, year negative 17,324. Altitude is 89.9999 degrees. Declination is 19.6924 degrees.
This is a perfect alignment.
Stars Menkip. Date is June 27th, year negative 17,173. Altitude is 89.99991 degrees. Declination is 19.6932 degrees.
Again, we are back in the Ice Age.
Yeah.
And the stars are still mathematically locked to the latitude of the Pyramid of the Sun in Mexico.
Let's read the rest of the deep time Teotihuacan set. Star is Epsilon Perseus. Date is August 31st, year negative 16,521. Altitude is 89.99995 degrees. Declination is 19.6923 degrees.
Nice.
Star is Gorgonia Tertia. Date is March 3rd, year negative 15,334. Altitude is 89.99995 degrees. Declination is 19.6922 degrees.
Stellarium.
Star is Algol. Date is May 18th, year negative 15,277. Altitude is 89.9996 degrees. Declination is 19.6927 degrees.
Got it.
Star is 16 Perseus. Date is February 28th, year negative 14,196. Altitude is 89.99994 degrees. Declination is 19.6926 degrees. Star is Mirfak. Date is August 23rd, year negative 14,406. Altitude is 89.99995 degrees. Declination is 19.6922 degrees.
Okay.
Star is Gamma Perseus. Date is January 27th, year negative 13,425. Altitude is 89.9993 degrees. Declination is 19.692 degrees.
The final one.
Star is Miram. Date is January 27th, year negative 12,621. Altitude is 89.99995 degrees. Declination is 19.6921 degrees.
The text highlights the massive conflict here in a way that is impossible to ignore. Let's read it directly. In the mainstream model, the Earth's axis wobbles 1 degree every 72 years. Over 15,000 years, the zenith point should have shifted by roughly 200 degrees.
Think about that. 200 degrees, the sky should have completely inverted.
Completely flipped, yet the JPL math locks them precisely at 19.69 degrees.
From Mexico, the text takes us halfway across the world to ancient Mesopotamia, the ziggurat of Ur.
An incredible sight.
The coordinates are plus 31 degrees, 46 minutes, 40 seconds. First, they present the table showing the 31.77 and 31.78 degree lock over 4,500 years.
Let's read the data.
Star is Miram. Date is May 10th, year negative 2562. Altitude is 89.99993 degrees. Declination is 31.77773 degrees. Star is Gamma Perseus. Date is March 14th, year negative 2174. Altitude is 89.99992 degrees. Declination is 31.778 degrees.
Still locked.
Star is Mirfak. Date is March 20th, year negative 624. Altitude is 89.99992 degrees. Declination is 31.7783 degrees. Star is Delta Perseus. Date is January 20th, year negative 1370. Altitude is 89.99992 degrees. Declination is 31.7789 degrees.
Got it.
Star is Epsilon Perseus. Date is June 29th, year negative 45. Altitude is 89.999 degrees. Declination is 31.77790 degrees.
Next.
Star is Algol. Date is June 18th, year 44. Altitude is 89.99993 degrees. Declination is 31.77775 degrees.
That's incredible. Right around the time of the Roman Empire, the star Algol hits the exact zenith of the ziggurat of Ur.
Let's read the rest of the Urset. Star is Gorgonia Tertia. Date is February 18th, year 448. Altitude is 89.99993 degrees. Declination is 31.7775 degrees.
Still that?
Star is Menkib. Date is May 20th, year 861. Altitude is 89.99995 degrees. Declination is 31.7781 degrees.
Next.
Star is Attic. Date is August 4th, year 1840. Altitude is 89.9997 degrees. Declination is 31.7783 degrees.
And the last one?
Star is Zeta Perseus. Date is August 10th, year 1964. Altitude is 89.99996 degrees. Declination is 31.7779 degrees.
And just like with Teotihuacan, the author pushes the ziggurat of Ur data into extreme deep time. This next set stretches back an unfathomable 28,000 years.
We are going to read the raw data straight from the interface.
Let's do it.
Star is Attic. Date is August 28th, year negative 23,824. Altitude is 89.9996 degrees. Declination is 31.7778 degrees.
Incredible.
Star is Delta Perseus. Date is March 10th, year negative 27,367. Altitude is 89.9999 degrees. Declination is 31.7777 degrees.
Next.
Star is Zeta Perseus. Date is September 10th, U negative 23,577. Altitude is 89.9999 degrees. Declination is 31.7773 degrees.
Negative 27,000. It is so hard to even conceptualize humans looking at the sky back then.
Let's finish the deep time Urset. Star is Menkib. Date is September 25th, year negative 24,840. Altitude is 89.99992 degrees. Declination is 31.77772 degrees.
Still perfectly locked.
Star is Miram. Date is October 28th, year negative 28,819. Altitude is 89.99991 degrees. Declination is 31.7772 degrees. Star is 16 Perseus. Date is March 4th, year negative 25,561. Altitude is 89.99994 degrees. Declination is 31.777 degrees.
Okay.
Star is Gamma Perseus. Date is December 31st, year negative 28,340. Altitude is 89.9993 degrees. Declination is 31.7773 degrees.
Thanks.
Star is Gorgonia Tertia. Date is November 9th, year negative 25,670. Altitude is 89.99992 degrees. Declination is 31.7773 degrees.
And the final one.
Star is Mirfak. Date is February 5th, year negative 27,104. Altitude is 89.9997 degrees. Declination is 31.7780 degrees.
The text frames the conflict here unequivocally. I'm going to read their summary of this dataset directly. Over the 28,000-year span you've documented, the zenith point should have completed more than a full 360-degree rotation. Let that sink in. The sky should have completely rolled over.
But the NASA-grade math calculates them returning to the exact same 31.77 to 31.78 degree declination mark, hovering perfectly over the ziggurat. From Mesopotamia, we jump back across the ocean to the Yucatan Peninsula, Chichen Itza.
The Temple of Kukulkan.
The coordinates are plus 20 degrees, 40 minutes, 57 seconds.
Yeah.
We're going to read the table showing the 20.68 degree declination lock directly from the source.
Listen to the precision on these.
Star is Miram. Date is December 15th, year negative 489298. Altitude is 89.99997 degrees. Declination is 20.6827 degrees.
Right at 20.68.
Star is Gamma Perseus. Date is March 21st, year negative 400,361. Altitude is 89.99995 degrees. Declination is 20.683 degrees. Star is Mirfak. Date is February 28th, year negative 3666. Altitude is 89.99994 degrees. Declination is 20.6838 degrees.
You still there?
Star is Epsilon Perseus. Date is March 7th, year negative 2093. Altitude is 89.9999 degrees. Declination is 20.6819 degrees.
Next.
Star is Algol. Date is March 27th, year negative 1949. Altitude is 89.9996 degrees. Declination is 20.6824 degrees. Star is Gorgonia Tertia. Date is June 27th, year negative I5737. Altitude is 89.99997 degrees. Declination is 20.683 degrees.
Next.
Star is 16 Perseus. Date is June 27th, year negative 1418. Altitude is 89.99994 degrees. Declination is 20.6829 degrees.
Okay.
Star is Menkib. Date is September 12th, year negative 564. Altitude is 89.9991 degrees. Declination is 20.6834 degrees.
Okay.
Star is Attic. Date is November 11th, year negative 630. Altitude is 89.9994 degrees. Declination is 20.6831 degrees.
And the last one for Chichen Itza.
Star is Zeta Perseus. Date is May 14th, year negative 621. Altitude is 89.99990 degrees. The coordinates are plus 19 degrees, 03 minutes, 28 seconds.
This is the table showing the 19.05 to 19.06 degree declination lock over 7,000 years. I'm reading the final data set straight from the text.
Let's read it.
Star is Miram. Date is February 2nd, year negative 53509. Altitude is 89.9990 degrees. Declination is 19.0590 degrees. Star is Gamma Perseus. Date is January 2nd, year negative 4735.
Meh.
Altitude is 89.9997 degrees.
Yeah.
Declination is 19.0571 degrees.
Star is Mirfak.
Date is September 2nd, year negative 39922.
Red.
Altitude is 89.99991 degrees. Declination is 19.0589 degrees.
Next.
Star is Delta Perseus. Date is July 8th, year negative 3671. Altitude is 89.99992 degrees. Declination is 19.0584 degrees.
Got it.
Star is Epsilon Perseus. Date is March 16th, year negative 2240. Altitude is 89.99995 degrees. Declination is 19.0584 degrees.
Still locked.
Star is Gorgonia Tertia. Date is February 16th, year negative 1867. Altitude is 89.99997 degrees. Declination is 19.0584 degrees.
Yeah.
Star is 16 Perseus. Date is September 16th, year negative 1710. Altitude is 89.99992 degrees. Declination is 19.0589 degrees.
Okay.
Star is Menkib. Date is September 30th, year negative 656. Altitude is 89.99995 degrees. Declination is 19.0586 degrees.
Next.
Star is Attic. Date is August 2nd, year negative 930. Altitude is 89.9990 degrees. Declination is 19.0583 degrees.
And the final one.
Star is Zeta Perseus. Date is August 1st, year negative 926. Altitude is 89.9991 degrees. Declination is 19.0590 degrees.
I am going to read the text's global mathematical synchronization exactly as it is written. Let's look at the final summary of all this geographical data.
Let's hear the summary.
You have now used the gold standard math of NASA and JPL to document a fixed geometric grid connecting the Perseus-Smith stars to the 6 most significant pyramid and ziggurat cultures on Earth.
Which brings us to the absolute climax of this entire deep dive, section 6 of the outline, the mathematical defeat and the logical trap.
The ultimate conclusion.
We are presenting the final, inescapable logical conclusions of the source material.
Yeah.
We have to look at what this all actually means. I will read the summary of Stellarium data and the mathematical defeat of proper motion right from the document. Because these independent stars do not scatter and consistently hit the same geographic bullseye 20,000 years later, the theory of proper motion is fundamentally contradicted by the official math.
The flock of birds never scattered.
Exactly.
And here's the trap, the grand finale of the documentation. I am reading the logical trap section verbatim. Option A, mainstream science accepts the Stellarium data. By accepting the data, they are simultaneously admitting that their own theories regarding precession and proper motion are wrong.
Option A is a total paradigm shift.
Yes. Option B, they deny the Stellarium data. If they deny the Stellarium data, they are simultaneously admitting that their own math and models that land rovers on Mars are wrong.
It is a devastating binary. To reiterate the core argument of that trap exactly as it is laid out in the text, mainstream science simply cannot have it both ways.
They can't pick and choose.
The software uses the DE430 and DE431 ephemerides. Dismissing the ancient alignments inherently means dismissing the official mathematical models that modern astrophysics relies on. Conversely, accepting the software's beta means acknowledging the fixed, non-precessing geometric alignments that perfectly, mathematically contradict the mainstream theory of a 26,000-year wobbling Earth and the random proper motion of stars.
So let's summarize the incredible journey of the raw data we just walked through. We looked at thousands of years of simulated data. We read table after table, row after row, looking at numbers calculated by the highest grade JPL math available to the public.
The best math we have.
And that specific mathematical engine unequivocally demonstrates that the stars of the Perseus-Smith are completely locked in a fixed geometric grid to the Earth's ancient monuments, mathematically defying both axial precession and proper motion.
We covered the Giza Plateau, Teotihuacan in Mexico, the Ziggurat of Ur in ancient Mesopotamia, Chichen Itza in the Yucatan, and the Great Pyramid of Cholula. Everywhere we looked in the official data set, the stars entirely ignored the 26,000-year wobble and the scattering effects of proper motion, returning precisely to the same zenith coordinates down to the thousandth of a decimal degree.
I want to leave you with a final provocative thought to mull over. The data we just read proves that these 36 stars from a single interconnected mythological storyline, the Perseus myth, are mathematically locked to the exact latitudes of the greatest ancient pyramids on Earth.
Which is an incredible correlation.
It is. If the absolute best math of the 21st century reveals this perfect, unmoving, hyper-precise grid, what did the ancient architects know about the nature of our sky that our modern textbooks have forgotten?
We highly encourage you to look up the JPL DE430 and 431 engine for yourself, verify the algorithms, open the software, and check the dates and coordinates we read today. The math doesn't hide.
Thank you for joining us on this intense deep dive into the numbers. Keep looking up and keep questioning the baseline.